Hello everyone. In this video we are going to study how to write down thermochemical equations for the formation of ionic compound using Hess law. So there is a lot of information we are going to learn in this lecture. For example, we will learn what is a thermochemical equation, how to write down thermochemical equations, what is Hess's law, and how we can apply Hess's law to find a formula for doing calculations. Okay, first of all, let me give you a brief introduction about Hess's law, how you can have a quick revision about the Hess's law. Okay, what is Hess's law? There are two pieces of information that you must remember about Hess's law. Number one is, according to Hess's law, whenever a chemical process takes place, every chemical process can take place through two different paths. One path by which a chemical process can occur, it is known as direct path. One path by which a chemical process can be completed, it is direct path, and the other path by which a chemical process can be completed, it is known as indirect path. Now what is the difference between direct path and indirect path? It is very simple to be remembered. Direct path means that involves one step only. Whenever we are able to complete a chemical reaction using one step only, we call that direct path. And if a chemical process needs two or more than two steps, then that path will be will be known as indirect path. So one thing that you must remember about Hess's law, that according to Hess's law, a chemical process, it can occur through two different paths, either through direct path or through indirect path. A second information that is even more important according to Hess's law. Now, whenever a chemical process takes place, whether it has been completed through direct path or indirect path, the enthalpy change, the energy released, the energy absorbed, the energy involved during the direct path and during the indirect path, it would always be equal. So what does this mean mathematically? Mathematically, we can write down enthalpy change of the direct path, it would always be equal to enthalpy change of the indirect path. So these are the two important pieces of information. Whenever you want to have a quick revision for the Hess's law, you must remember, number one, a chemical process can be completed using direct path and indirect path, and number two, enthalpy change of the direct path, it is always equal to the enthalpy change of indirect path. Okay, now you have come to know what is Hess's law, what is the most important information that you must have in your mind for the Hess's law. Let's take the example of an ionic compound like aluminum oxide, that is Al2O3. Now we are going to write down thermochemical equations for the formation of this ionic compound, but what you must remember, as I told you, we can prepare aluminum oxide using two different paths, direct path and indirect path. In the direct path, it is quite simple. You will take the two elements present in aluminum oxide, aluminum metal and oxygen gas. You will combine them, you will get aluminum oxide. This is direct path because in simple one step we have become able to produce aluminum oxide. But for as far as indirect path is concerned, that is important to be remembered, that for the formation of any ionic compound through indirect path, always three steps are involved. Yes, how many steps? Three steps are involved for the formation of any ionic compound. Number one, atomization. First of all, we have to atomize the element so that they can become reactive. Then atoms, since we want to make ionic bond, atoms, they must be ionized. So the second step will be ionization. And in the third step, ions combine to produce the solid lattice. That is the formation of ionic lattice. So simply remember, during the formation of any ionic compound, three steps are involved in the indirect path. Number one, atomization of elements. Number two, ionization of elements. And number three, formation of ionic lattice. Let's start. If we want to prepare aluminum oxide is a solid. We can combine with which elements to prepare aluminum oxide? We can combine aluminum metal, it is a solid, and oxygen, O2, gas. These two elements, they can combine and they can give us aluminum oxide. Now to balance this equation, since we are interested to prepare 1 mole of aluminum oxide, So we will balance the equation accordingly. So we will balance only the left hand side of the equation to keep 1 mole of aluminum oxide on the right hand side. So how many mole of aluminum we need? We need 2 mole of aluminum, and there are 3 atoms of oxygen on the right hand side. To balance oxygen, we have two options. Either we can use the coefficient of 1.5 or 3 by 2. Any one coefficient you can introduce. Okay, I'm introducing 3 by 2 O2. So now this is a balanced equation. This is a balanced equation for the formation of aluminum oxide through one step. So this is the direct path. Now, what is the difference between a simple balanced equation and thermochemical balanced equation? Now we are going to convert this simple equation into a thermochemical equation. Simply what we will have to do, whenever you want to convert an equation from simple form into the thermochemical equation form, you will have to introduce enthalpy change of that reaction on the reaction arrow. There are two possible ways. Either you will introduce the numerical value of the enthalpy change, or you will use the symbol. You can label the enthalpy change for that chemical reaction. For example, in this case you can see there is the formation of aluminum oxide. So the enthalpy change of this step can be known as standard enthalpy change of formation. So on the reaction arrow you can introduce standard enthalpy change of formation of aluminum oxide. Now this chemical equation is known as thermochemical equation. So this is the difference between simple equation and thermochemical equation. Okay, also we have completed the direct path. Let's proceed to the indirect path. What I told you, in the indirect path, first step is atomization of elements. You will have to atomize the element. So let's atomize aluminum first. What you should remember, what is atomization? Atomization is very simple. Any element, whenever you want to atomize it, just write down the symbol of that element, and along with the symbol at the base you should write down state symbol gas. This is atomization. We have an element in the gaseous form, it is atomization. Symbol of element and the state gas. Likewise for oxygen, we can atomize, we can use the symbol. There are 2 mole of aluminum, so you can balance aluminum after atomization. Likewise, after aluminum we can atomize oxygen. The symbol of oxygen, state symbol gas, and since there are 3 atoms of oxygen, we will multiply this oxygen by 3. Now you can see we have atomized both the elements. Now since elements have been atomized, we have involved some bond breaking, so some enthalpy change is involved. But that enthalpy change is known as, whenever atomization takes place, that enthalpy change is known as enthalpy change of atomization. So you can label enthalpy changes on this reaction. Number one, for oxygen you can write on atomization of oxygen multiplied by 3, because there are 3 mole of oxygen. So for each mole of oxygen we have to use enthalpy change of atomization. Likewise for aluminum, we will use enthalpy change of atomization of aluminum multiplied by 2, because there are 2 mole of aluminum. Okay, now this is the first step for the indirect path for the formation of ionic compound. Our elements, both aluminum and oxygen, they have been atomized, but they cannot make ionic bond because they are atoms, they are not ions. You will have to convert them into ions. How you can convert them into ion? Aluminum is a metal lose electron. This metal aluminum will lose 3 electron. So what will happen? One aluminum, to make iron, it will lose 3 electron and it will carry a charge of 3 plus. Now aluminum has been ionized. One aluminum has lost 3 electron. We are having 2 mole of aluminum. So 2 mole of gaseous aluminum ion will produce in total 6 mole of electron. So remember, we have got 6 mole of electron from 2 mole of aluminum. Where these 6 mole of electron they will go? There is oxygen. Oxygen will also undergo ionization. Oxygen is a non-metal. Non-metals gain electron. One oxygen belongs to group number 6. In its valence shell there are 6 electrons. So oxygen is in need of 2 electrons. So that is why one oxygen will gain 2 electrons. If one oxygen will gain 2 electron, it would get a charge of 2 minus, and 3 oxygen, when they will gain each one 2 electron, how many electron 3 oxygen would have gained? 6. So you will see the number of electrons lost and the number of electrons gained would become equal. Okay, before that, aluminum, it has lost 3 electrons. Whenever electrons are lost, the enthalpy change for that step is known as ionization energy. 3 electrons have been lost. If 1 electron is lost, it is known as first ionization energy. Aluminum has lost 3. So we will write down first ionization energy plus second plus third ionization energy of aluminum multiplied by 2, because there are 2 mole of aluminum. So try to understand this step, that for each ionization energy, for each electron lost, we write down 1 ionization energy, and 2 we have multiplied this whole by 2, since there are 2 mole of aluminum ion. Now I told you that the electron lost, they would be gained by the oxygen. So one oxygen will gain 2 electron, oxygen would get a charge of 2 negative. Now 3 moles of oxygen are there, so we will get 3 moles of oxide ion. But whenever electrons are gained by an atom, the enthalpy change, it is known as electron affinity. Right now oxygen has gained 2 electron, so it would be having first and second electron affinity. So you can label on the reaction arrow the enthalpy change. It would be first plus second electron affinity of oxygen multiplied by 3, because there are 3 mole of oxygen. Now we have completed the 2 steps of the indirect path, atomization and ionization. Now ions, they carry opposite charges, so they have natural tendency to attract each other. They will attract each other, they will make a bond with each other. That bond is ionic bond, resulting in the formation of ionic lattice. And whenever an ionic bond is formed, an ionic lattice is formed, the enthalpy change of that step is known as lattice enthalpy. So here you will write down lattice enthalpy. Now you can see you have written thermochemical equations for the formation of this ionic compound aluminum oxide using Hess's law. Using Hess's law means we have used both the paths, indirect path and the direct path. Now let's apply Hess's law on these thermochemical equations to get a formula that we could use for solving numerical problems. Okay, how to apply the Hess's law? See, whenever you want to apply Hess's law on a set of chemical equations, on thermochemical equations, you must identify what is the initial stage, what is the final stage. Now what is the initial stage? Simply how you can understand, initial stage is the one from where all the arrows, they take a start, where we have tails of all the arrows, and final stage is the one where all the arrows end up, where all the arrows, they are having their heads. So can you identify which stage in these thermochemical equation, which stage is the initial stage and which stage is the final stage? Okay, I am telling you, this is the initial stage. Did you identify this? I hope you would have. Okay, if this is the initial stage, why? Because 2 arrows, they are taking start from here. One arrow is moving in the forward direction, other arrow is coming down, and both the arrows, they are showing tails to this position. So keeping this thing in mind, now you would have become even more comfortable how to identify the final stage, where both the arrows, they are touching their heads. This is the final stage. So whenever you want to apply Hess's law on thermochemical equations, you must first identify initial stage and final stage. After that, you must label, you must identify the resultant vector. The resultant vector is a one arrow, that is the sum of all the other arrows. And remember, resultant vector is single arrow, that is equal to sum of all other vectors, sum of all other arrows. Right now, which one vector? I can also tell you like this, you can remember, whenever you wrote thermochemical equations for the formation of an ionic compound, always remember direct path, standard enthalpy change of formation, it is the resultant vector always. So right now, which arrow is the resultant vector? That would be the sum of the all other arrows. This one. Standard enthalpy, just remember, standard enthalpy change of formation in case of formation of ionic compound, standard enthalpy change of formation is the resultant vector. So now let's write down the formula. Standard enthalpy change of formation of aluminum oxide, it is equal to atomization of aluminum multiplied by 2 plus atomization of oxygen multiplied by 3. So now we are going to take the sum of the remaining 3 arrows, plus first plus second plus third ionization energy of aluminum multiplied by 2 plus first plus second electron affinity of oxygen multiplied by 3 plus lattice enthalpy of aluminum oxide. So you can see now we have also come to know what is the formula by applying Hess's law for this for these thermochemical equations. Now by using this formula we can solve a numerical problem where we are asked to find the numerical value of some unknown enthalpy change. I hope you would have enjoyed this lecture. Thank you for your time. Bye bye.